All right, so we're live. Let's continue our discussion of the Veritasium video. I was thinking about what he thinks. Maybe I have an idea what he's thinking. I don't know yet, but well, I mean, I will discuss it anyway. Let's play his video. Oh, we need to. I just wanted to make sure that my audio is good. All right, so we can continue.
Of the mass at r equals 0, this term is divided by 0. So it blows up to infinity.
It blows up to infinity, as we said, because of the assumption of a point mass. So I'm assuming this is the assumption that Schwarzschild made. He made an assumption that he has a point mass. Okay, so if you assume a point mass, obviously at r equals 0, you're dividing by 0. That's part of the assumption. So the assumption, I mean, where Schwarzschild should have written, you know, that his equations, whatever he's trying to develop, does not apply for r equals 0. And as r approaches 0, it becomes irrelevant because it's an assumption. And in reality, um, we, I mean, so the question is, in reality, what's going on? I mean, if he is, I don't know what he's assuming. I mean, you can assume a point mass from a distance, but as you get close to something like the sun or the earth, you realize that it's a ball of whatever, of a soup, of a complete mess of densities. Um, but the question is, what happens when something becomes a black hole, when something gets crushed to almost a point? What happens then? So, but but that that was not the assumption that Schwarzschild made when he started his analysis. I mean, you can't assume a point. I mean, he assumed a point mass just to simplify, right, as the simplest case. He wanted to solve for the simplest case. So he said, okay, let's assume a point mass. That's the simplest case. Um, he could have assumed anything. He could have assumed a sphere instead of a point mass, a spherical mass or a ball mass. At r equals 0, he would still get infinity. Maybe, I don't know. But it's just the assumption. If you assume something that is ridiculous, then you get something ridiculous in the. You might get something ridiculous in the conclusion. Anyway, so I mean, this goes back to the assumption. He assumed a point mass. This is why I kept stressing when Veritasium kept explaining the spherical, the center of the sphere of the mass and stuff. That's why I kept nagging, or I kept questioning what exactly does he mean? What exactly is Veritasium thinking about? What did Schwarzschild think about? I don't know. I mean, if it's a point mass, then obviously it's something that has an infinite density. A point mass, by definition, has an infinite density. So that's not something that we know exists. What would it even be? I don't even know what it would mean to have an infinite density. But the assumption is ridiculous, which means you're just supposed to stay away from r equals 0, even r approaching 0. As r approaches 0, you're going to get something bizarre. But that is the assumption. That's it. That is what happens when you try to simplify, when you try to build a model, a simple model of reality. It's not reality. So when something is simple, it ends up being ridiculous different, I would say, edge cases. Okay, let's continue.
infinity, and therefore this equation breaks down and it can no longer describe what's physically happening. This is what's called a singularity.
Singularity just means a mathematical singularity just means it's a placeholder for we don't know what's going on. So to call it a name, you might it just means undefined. I don't know why the word singularity was invented. It's confusing. It sounds like it's something that we do understand, but it's not. It's just a placeholder. Something that we don't understand happens. The word singularity is not supposed to add information. It's just supposed to say we don't know what's going on. The equation does something that we or whatever we just don't know what's going on at this point. That's all it means. It means undefined placeholder. We need to look deeper into this.
Maybe that point could be excused because it
Maybe that point can be excused. That is a bizarre sentence. Maybe that point can be excused, right? Because it's in the middle of the mass. Again, it's what do you mean it's in the middle of the mass? It's a point mass. And what do you mean? Let's roll back the tape. Okay, so again,
called a singularity. Maybe that
maybe that point could be excused. What does that mean? What do you mean by maybe? I don't know what maybe means. I mean, can it be excused or can it not be excused? Or you don't know, no one knows. I don't know. What do you mean by maybe? I mean, you had a list of celebrities or a list of professors look at your script and look at this video and you got and you had consultants and you have 15 trillion subscribers and at the end you have a maybe. I don't even, what does that mean maybe? That point, so okay, it's a point, could be excused. What do you mean excused? What do you mean? So I gave an explanation that this follows from the math. It's a crisp explanation. There's nothing, there's no maybe in my explanation. I don't excuse a point without perfect mathematical reasoning. Of course, that point should be excluded unless it's up to you. I mean, it's the assumption. You made an assumption of something unrealistic. You made an assumption that you have an infinite density. You made the assumption. Okay, you made the assumption of an infinite density, then okay, it's obviously ridiculous. I don't know what infinite density is. So that's that so yeah, I explain why quote that point should be excused or should be excluded. I don't have a maybe, and I don't say excused, I say excluded. This happens all the time when you define systems. Then you say in the beginning for r not equal to 0. Also, r a negative number. Does it make sense for r to be a negative number? Obviously not. What is a negative number for r? Or an imaginary, if r equals I, does this have any meaning? If r equals the square root of negative 1, does this equation hold? Of course not. It it doesn't mean anything. As far as I'm concerned, as far as math is defined. So anyway, let's continue from here.
point could be excused because it's in the middle of the mass.
What do you mean it's in the middle of the mass? You can say it's in the middle of the geometry of your coordinate system. It's not in the middle of the mass because you assumed a point mass. This is where the problem comes from. Why do you keep saying the middle of the mass? I don't understand.
But there's another problem spot outside of it. At a special distance
All right, we have a visitor. Yeah. Oh, Aviator, what's up?
Hello.
Hi, how are you? You ran away last time.
I ran away, did I?
Yep. Soon as I asked you why should I respect the bimbo community, you ran away.
Oh, that stupid thing you.
Y-
Brother, I don't even know what you're on about back then. Like, you were saying you were pronouncing community wrong, you kind of pissed me off, so I just left.
Oh, I'm sorry. That was Eric Cartman. I said it's the Eric Cartman version of how you pronounce things. I didn't. Yeah, okay, I'm sorry. If that's the reason, then fine. But in general, the question stands, why should I respect the scientific community? I'm not saying I don't. I'm just saying, I mean, I respect everyone. I respect you just as much as anyone else. I don't even know what the scientific community is. It's not like there is a community of scientists or of scientific
I'm more interested in the topic of your channel. Um,
topic of.
what happens?
Mm.
What is the strange thing that you discovered, Mr. Slave?
It's a video review that I'm doing as we speak. Right now, you're on YouTube, if you don't mind. Let me let me
Uh,
post a link. Do you mind?
Not particularly.
Okay, so let me just post a link to this video response that I am in the midst of. There is the link.
By the way, I I can't say your name, but Cat dude, you're on YouTube right now. By the way, a famous YouTuber
Ex Caracalla.
is doing a live stream right now.
Ex Caracalla is a
Oh,
good,
that's right. Okay.
yeah, he's a good friend, and apparently Caracalla is one of the famous uh, Caesars of the Roman Empire. Apparently, so it's a famous name. Apparently, anyway, so the video that I'm reviewing is by a very big scientific communicator called Veritasium. He has almost 16 million subscribers. So obviously he has the truth, as you can tell by the number of subscribers. So he made a video about basically black holes. You know, the center of the black hole and okay, he's gaming. And the event horizon of the black hole, and parallel universes, and wormholes, and white holes. So I'm just reviewing it. This is the third video that I'm making. I'm going like really slowly, like doing a slow analysis of literally everything he says. Are you there, Aviator?
Yeah,
Do you have any questions? You
I'm
want
just
to add?
eating right now.
What?
I'm eating right now, so forgive me if I'm not speaking
Oh,
as much as I usually would. But
hmm
what have you figured out so far? So you wouldn't have made this channel if you haven't found something interesting, right?
so as I'm going through it, it made me think about general relativity and
Mm-hmm.
how it came about, and the fact that Newton couldn't figure out how gravitation works. How does an apple fall from the tree? Because there's no wire that's pulling the apple towards Earth. So why does the apple decide? What?
That's the thing. He did figure it out.
No. No, Newton said that he did not figure it out. He can give us a formula, an equation for how it, he can describe the falling of the apple, and he can describe the falling of the moon towards Earth, and therefore the moon's orbit. So he can give us a description, but he couldn't figure out how does it work without a wire. He said that
Sorry, what? No, he created the concept of the universal law of gravitation. So everything, everywhere, all objects in the universe are currently attracting each other via gravity.
right,
Correct?
correct, but then
Okay.
yeah, but that ended up being incorrect or incomplete.
Okay. Okay. Sure. Sure. Yeah. Go
So
on.
no, but Newton, there is a quote that Veritasium brings in the beginning of the video, quote from Newton, and that quote is incredible. Newton said that if you think that the force of gravity is mediated between I don't remember if he says the Earth or the Moon or two bodies through the vacuum, then you need to have your mind examined, or you're out of your mind, or like really, really harsh words. He said, if you think that the force of gravity is mediated over a vacuum, you are insane. That is as impossible as he thought it could be. That cannot be, Newton felt. Newton was of a conviction that that's impossible. And so, as you said, Newton gave us a law of gravitation. He didn't give us a theory of gravitation. He didn't have a simple model to explain from first principles why how gravity works. So and then I think like 100 years later, Einstein was thinking about, I'm not sure what he was thinking about, but it occurred to him something called the equivalence principle. It occurred to him that a person, I think he was sitting at his office, maybe the patent, I don't think it was the patent days anymore. I think this is after already he became famous. But he was having a thought that he's sitting in his office and somebody was falling out his window, and he said that person falling is actually experiencing free fall. He's experiencing no forces acting on him. So that person actually is might as well be in outer space alone in the universe. And 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 um and he and he came up with the equivalence principle that says that if you're in an elevator or if you're in a closed room and you don't know where you are, and all you can feel is as you feel right now, you feel the earth is pulling you down. He said you actually don't know that. You might be in a spaceship that is currently accelerating upwards. And there's no experiment you can conduct to tell if you're in a spaceship accelerating upwards or if you are sitting on Earth with the gravity pulling you down. So he made an assumption that there is no experiment you can conduct to tell the difference.
You made an assumption.
Yes,
No, it's true. It's true.
yes.
If it's all reference frames, so if there's no test that you can really do, like you said, to figure out who's moving, you or the um you're the Earth, right? So it's
No,
correct. It's you really can't do an experiment like that.
no, 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 no. There's no experiment you no, no, no. There's no experiment you can conduct to know if you're in a spaceship. Let's say there is no universe. There's an empty universe and you are in a spaceship. So one option for you right now is that you're in right now sitting, imagine you're sitting in a closed capsule and you cannot look outside. But all you can feel is if you drop things, they fall down, and you feel sucked towards down, down. You're sucked down. You're being pulled downwards towards your feet, and you feel pressure. If you're sitting, you feel pressure against your thighs, against your feet. Something is pushing you upwards. That's all you know. And the question is, are you right now uh, on Earth? Let's say you're in a closed capsule, so you cannot look outside. So you need to figure out, are you right now on Earth, sitting still, being pulled down by gravity? Or alternatively, are you actually in a spaceship in an empty universe accelerating upwards because the engines are pointing downwards? So Einstein said that there's no way ever you could tell one way from the other. There's no scientific experiment you can conduct to tell the difference. That is the equivalence principle. It's also
Well,
Mhm.
hold on. Really, it would be the the spaceship is traveling upwards, wouldn't it?
No, there's no way you can tell right now. If
Well,
we
I know, but you said it would be whether or not it's, you know, uh, whether or not it's moving or not.
no
I think,
no, the point is there's no way you can tell, and because there's no way you can
yeah,
no because
yeah.
there's no way you can tell. From that, he figured out general relativity, like crazy things about reality. And from that, you can get back Newtonian gravity. So he can figure out Newtonian gravity just from the equivalence principle. Newtonian gravity is a simplification of general relativity. So where Newton needed Kepler to give him his laws, and from Kepler's laws, Newton figured out the equation for the force of gravity. Einstein didn't need. Kepler needed Tycho Brahe's notes, and there was a big legal war before Kepler got the notes, because Tycho Brahe had the data. Tycho Brahe used to lie on his back for his entire life, just looking at the stars and writing down their locations. From that, Kepler figured out the laws of equivalent areas, and from that, Newton figured out the law, what you call the universal law of gravity. So it's all from Tycho Brahe, Tycho's work and Kepler's work. And came along, had Einstein, and he said, I don't need that. I mean, he didn't even, I don't think he aimed in that direction. He thought about relativity. He was thinking about, well, I don't know what he was thinking about, but it occurred to him that this equivalence principle, and from that he figured out how gravity works. He actually figured out that that objects with mass warp the geometry of the universe and cause space itself to flow, which is incredible. And from that, you can, once you assume that, you should be able to derive Newton's gravity as a simple case, as a primitive case.
Very interesting. So, so what's the strange thing that happens when you follow Einstein?
The strange thing,
That's my question.
in Veritasium's video, there's a bunch of strange things. One is that you get an infinity in the center. Uh, it's not so clear in the center of a black hole or something. You get some infinity, and you get also an infinity at the event horizon, whatever that is. And you get, besides when you get a black hole from the math, you get also a white hole on the other side, and you get a wormhole to connect them, whatever those are. And and from the black hole, you should be able to come out into a parallel universe. And these are the strange things that happen when you follow Einstein's math. I don't think that's true. First of all, you don't need Einstein's math for the event horizon. You can deduce the event horizon from first principles without math. And the white hole and the wormhole, I think, are just mathematical artifacts. I don't think we can for now we don't know what happens inside a black hole. For now I don't know. So I don't know. Einstein's math is based on an intuition. So I don't think you can come up with anything unintuitive from the math. So the math is built on intuition. So if from the math you come out with something strange, then that I don't think that makes sense. That cannot make sense. It's all built on intuition. So I don't think you can end up coming up with something strange. So, unless it's a mathematical artifact. It's a byproduct of the math. Don't forget, math is not reality. Math is a simplification. It's a simple model of reality. There is no math in reality. Reality doesn't know mathematics. So the math is a simple model of reality. So if you end up with strange artifacts in the math, then you should that's a problem with math. Math has problems. That's. So you should be able to trace anything weird back to the math, not nothing that this it cannot be. It cannot be. I don't think it can be related to reality. So a white hole, if in intuition you cannot imagine a white hole, then who cares what the math says? If the math says there's a wormhole, why should you care? Can you intuitively figure out a wormhole connecting the black hole to a white hole? What does that even mean?
Yeah, but we can't intuitively declare that the proton exists, but we know it exists because of maths and science and deduction, right?
Um, that's a good question. The proton doesn't come out of math. The proton comes from
What
very simple experiments that you can reproduce at home. If you had
simple
the,
experiments, such as
I mean, what you're showing is that it's the sad case of science today that people don't know how the proton was discovered. I actually I don't know how the proton. I know how the nucleus was discovered. I don't
yeah,
remember. You know how the nucleus was discovered? I mean the
yeah,
atomic nucleus.
yep.
All right, so the atomic nucleus was really straightforward. I don't remember, unfortunately, how the proton.
Uh,
Mhm.
But again, the point is, look, just by virtue of you not knowing instantly, some things you just don't figure out from intuition. You figure them out through dedication, through deduction, and through hard work and persistence. And it seems to me that you could apply it to a lot of things in our world. Just because we haven't figured them out through intuition doesn't mean they're not real or not there.
But general relativity comes out of intuition.
Does it now?
What?
Does it?
Yeah.
Go on then.
So general relativity describes the fabric, not even the fabric. It goes one layer deeper. It goes into the geometry of the universe, which is the last thing you'd expect is for the universe to be aware of a geometry. But apparently, the universe has a geometry. And when something with a mass like the sun sits there in the middle of nowhere, the geometry is curved. That's what general relativity says. And because the geometry is curved, then space starts flowing into the sun. That is what general relativity says. That has to happen. And because space flows into the sun, it drags in the earth, it drags in everything. And the only reason we don't fall into the sun is because we're moving in a tangent line to the sun. So we end up stuck in an orbit. But this orbit, the reason when the Earth is not flying off in a straight line, in a tangent line away from the sun, is because space itself is flowing. Space is a literal river that the Earth is sailing on. So the Earth is on this river. The Earth, and this river has no friction because this river is actually stationary relative to Earth on top of everything. If you thought that's weird. So special relativity says that the water in this river, it's a three-dimensional river. So the universe is a very deep pool of water. The universe, you can look at it as if it's filled with water. The reason why you don't feel this water is because this water is stationary relative to you. This water is stationary relative to an observer. And the only way an observer can feel this water is through acceleration. Anyway, it's bizarre. I would say it's incomplete, but this comes out of the just the equivalence principle, which is, as you said, it's an assumption. It's just intuition. So because of this intuition, you end up with something like a black hole, because so the sun sucks in space and space flows into the sun. And the more massive the sun becomes, let's say we pour more and more mass onto the sun. Let's say we add another sun. We bring in another star and we dump it on the sun. And now the sun becomes heavier and heavier. As we pour on more material onto the sun, it becomes heavier and heavier. As the sun becomes heavier, this sucking of space, the flow of space into the sun increases. It speeds up. And as we add more and more and more material onto the sun, the space flowing in speeds up more and more and more and more. At one point, the speed of the space flowing into the sun will reach the speed of light. At that point, the sun has become black. And that's called a black hole because it looks like a hole in space. And if you keep increasing the mass of that sun, of that black hole, then the speed of the space flowing into the sun will increase beyond the speed of light. There's no reason why, there's no reason that space should be limited by light speed. The speed of light is a speed limit for observation. There's no limit on space. Space is not limited to any speed, as far as I know. So, so the space can flow in.
Well, okay.
Go ahead. What?
No, as far as I know, it is impossible to go faster than the speed of light. I think it's a commonly accepted truth about the universe.
Yeah, you keep referencing opinions. I don't care for opinions. I only work from first principles.
So it's a mathematical truth.
No, it has nothing to do with math. It has to do again with Einstein's
Okay.
intuition. So again, special relativity and this and the limitation, the limit of the speed of light.
Again, you well, look, his intuition, whatever you want to call it, was verified time and time again by observation. Um, Part of the Einstein's theory of general relativity is him trying to craft his theory, but trying to keep the speed of light the same, right? And just using that framework, we test his theory, and it's been validated. So it seems to me that some it's true, correct? If,
I
if,
wouldn't
if you if you
say
make this assumption, it turns out that your model with that assumption is correct, then it seems to me that you made the right assumption.
I wouldn't phrase things that way. I would phrase it either a little bit different or completely different. So you said it's a mathematical truth. So I said it has nothing to do with math.
Well, it does. I just let that go because
What do you mean? I'm
mm,
okay.
it does.
What do you
You only come to you only get to the point of creating a new scientific theory with maths. You can't. Okay, I'm not even gonna go down there because I don't want to get rowdy. But again,
mean?
Einstein built his entire theory on maths and logic and science. You don't get to where he was without using logic and science and maths. So
I have no idea what you just said, and I don't know. I, 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 I don't care about Einstein, where he got or
okay,
didn't get. Does I don't care. I only care about the truth.
yeah,
If he made assumptions, and through those assumptions he made predictions, and the predictions were validated, then that says something about the assumptions. The assumptions have been validated. I wouldn't use the word truth. I don't think usually it's a good word to use. It's like you can try to aim for the truth, but in science, I think we only look for to validate. That's like the best I would hope for. I don't want to say something is true because then I close my mind from the possibility that my theory could be invalid. And I always want to keep an open mind because I'm looking for the truth. To I'm looking for the truth. Therefore, I don't want to say that my theory is true. I want to say my theory has been validated for now. And um, I want to be skeptical about everything, including my success. I don't want my success to go to my head and then, and end up believing that my theory is true, where evidence
Mm,
might show up one day that it's not true. So I wouldn't use the word true except for as something that we aim for, but it's unattained. The way I work is I assume I never have truth. I have temporary validation.
mm,
There's a whiteboard.
interesting. Yeah, that's really helpful actually. Very helpful.
That wow,
Um,
yeah, that's what I
wait, no,
need.
what happened to
You want to go?
Yeah, 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 join it. I mean, you can. It might help you show how, from first principles, what Einstein is doing is just an assumption.
Yeah, we could do that.
Do it, please. Let's see the maths, all the stuff on that. You can be very,
But
very useful.
everybody's is if everybody's drawing, that's not good. I need to.
It's fine. Yeah, sorry, that was me. Just if you just do that, and then you can
Okay,
delete them
okay.
and zoom
So
out a bit as well.
okay, so let's derive.
Not a lot.
Let's derive. You want to derive general relativity from first principles without math. That's easy actually. That's not even
Please.
it's not even a challenge. I mean, there's many videos on YouTube that do this, but I think I do it just a
Yeah,
little.
there are.
Yeah, but they don't do it correctly. At the end of the day, I think my revelation from making this video or this set of videos about Veritasium, I finally understand the missing link, what Newton was missing. And no one, I don't think anyone, I mean, people have been using an analogy of water and flow to explain general relativity, but I think it's not an analogy. I think that is reality, and that explains gravity. Otherwise, we don't. We never answered Newton's question. Anyway, so let's prove general relativity from first principles. So let's say, how do I draw? Okay, so let's say I'm in. Let's say we have a person in a spaceship, and many people have demonstrated this. This is nothing new. This is all over YouTube. So
Yeah, zoom out, dude.
zoom out. Why?
Yeah, like a bunch until you can see the edges of the whiteboard, and then it's much easier.
Mm, okay, but let's zoom in to draw. How do I move? How can I
Yeah,
move? Is
you,
there
you hold space and
hold
hold
space?
space to pan.
Oh, that's good. Okay.
And then,
Okay. So let's say we have a person. Let's magnify. How do you magnify? Oh, okay. I see. You scroll. Okay, so let's put a person. He's standing in the spaceship because it's accelerating, so he feels the push of the bottom of the spaceship against his feet. So the spaceship is accelerating what we call upwards. Great, thank you for your help. Okay, now let's say we're gonna put not a laser. Let's start with a water hose on the side of the ship, and it's gonna let out a jet of water, or a jet of water at a very high velocity to the left. So uh, let's say it goes out almost at the speed of light at 300,000 meters per second. So, in order not to push to the right, it's going to just let out one molecule of water once per second. So, once per second, a molecule of H2O is getting shot out to the left at 99.999% the speed of light. So, what does the person in the ship expect to see when he looks at this jet of water going out from the ship as the ship is accelerating upwards? What is he expecting to see from a long? If we look at from far away, what should happen to this jet? Should it continue in a straight line, or should something happen to this jet of water? What do you think?
It goes down, right?
Right. So we expect it to bend, to curve downwards. So do they have Bezier curves in this app? Do they have Bezier?
What?
Bezier.
Bezier.
Bezier. Those are the way you draw curves. Usually you use Bezier curves. So,
I'm sorry, I've got no idea.
never heard of Bezier curves? Anyway,
No.
there's YouTube videos about Bezier curves. Anyway, so we expect as the ship accelerates, we expect this downward curve of the water, of the jet, right? It's pretty
Yeah.
straightforward. It's like you right now, if you take a garden hose and you let the water come out, the water is going to curve towards Earth. But this is also
Mm-hmm.
true when you're in space in a rocket ship. The water behaves the same. It curves downwards. Okay. So the next question is now instead of a water jet, what if we put a photon jet, also known as a source of light or a laser pointer? What do we expect, right? This water flows out at 99.999% the speed of light, whereas which is almost 300,000 meters per second. And this light comes out. We can measure the speed of light. It's 300,000 meters per second. What do we expect the jet of light to do? Should it continue in a straight line relative to the ship, or should it curve down just like the water? What's your opinion?
It's gonna bend, I think.
Right. So, can I'm thinking, can we prove it? Um, I mean, if the ship wasn't moving, then let's say there is a board here, like a blackboard, and before the ship was moving, both of the streams hit this blackboard. Before the ship was moving, both streams hit the blackboard. And let's say this blackboard, it's a very, very long blackboard. It's an infinite blackboard. So as the ship starts moving, the blackboard is still there. So when the ship is not moving, both streams hit the blackboard. Now that the ship is beginning to accelerate, what should happen to the light? I mean, we know, from our intuition, the stream should be curved. Should the light be curved? So I think,
Yeah.
why should it be curved? Why do you say that it should be curved?
Um, because the last time I saw a diagram on general relativity, that's the light curved. So I'm guessing it should be the
No,
same.
right, but we don't want to trust anyone. So here is the explanation. So when, right, you can either think of light as made out of particles or a wave. It doesn't matter. What matters is that light has a speed, and the speed of light It's finite. It's some number. It happens to be 300,000 meters per second. So let's say this is like a very long distance. Let's say this is 10 times that. This is 3 million meters. So it's going to take it, whatever. Let's say it's 10 seconds away. So when you fire the light, it's going to hit here 10 seconds later. All right. I don't know if you can see my pointer. It's going to hit here 10 seconds later. But by that time, the ship should already be here, which means that the light must bend. Just because light has speed, it must be curved.
Okay, but also it should take the same amount of time as the other one.
It should actually take a little bit more time because it's covering more distance.
No, right? Because light, wait, hold on, wait, lights has a constant speed, so damn, it's so
Right. No,
confusing.
no. So
Actually, no,
at
okay.
this point, I mean, light. If you draw a triangle, so the hypotenuse, right? This is the original distance that it had to cover at this point, but now it has to cover the hypotenuse, which is a little bit longer. So the length of the curve is longer than before. So it should take light a longer time to hit the board. At least, um,
Okay.
anyway, so so let's assume that for now. Let's assume that light curves. Okay, now since actually we cannot tell, this experiment now, I'm telling you, right? This experiment was done from the point of view of the person in the ship. And the person in the ship doesn't know that he is in a ship. He might be on Earth, sitting in his office. Therefore, light must bend because of gravity. If light bends because of acceleration, then light must bend also because of gravity. What do you think?
Um, I don't know. It's confusing.
Yeah, I agree. But look, the step from the spaceship to Earth, that should be the easiest step. That's the assumption we made. We made an assumption. I don't know if we stated it clearly, but that's the assumption Einstein made. That's the happiest thought that he had. That there's no experiment we can conduct to tell the difference if we're accelerating in a spaceship or if we are sitting in our office on Earth, sitting on a chair on Earth, or standing on the floor on Earth. There's no experiment we can conduct to distinguish. So the step from the ship, from assuming the person is in a ship to a person on Earth, that's the easiest step. The step
Mm.
that water that the water curves and light curves, intuitively we it's okay. I mean, it would be nice to also see it in reality, and I think people have done this. People have seen. You should be able to measure it. Like if you hold a laser pointer, let's say 1 meter off the ground and pointing parallel to the floor, and you have a board a few meters away at the same height, the laser point should be just a little below The laser pointer should hit just a little below where you aim, just like a water hose. When you aim with a water hose, you can never hit your target. You have to aim above. But if you increase the speed of the water coming out, then your target, then your target, then the water goes in a more and more straight line until if the water comes out of your hose at almost the speed of light, then it looks like a straight line, but it's not really a straight line. It's always just approximating. It's asymptotically approaching a straight line as the water comes out faster and faster. So like at 99.999% the speed of light, it looks like a straight line. But if you over a great distance, you will see that it's bending, that gravity is pulling the water down. And with water, of course, you expect water to be pulled down because water has mass. But then you try it with light, and light has no mass.
Mm.
That's the revelation of Einstein, that it's not mass. So that's unbelievable. It's actually light that has no mass should also get dragged down. So it's not a force between two objects. It's something that happened to the geometry. It's something that happened to space itself. It's something that happened to the universe. It's a field. So the gravitational pull of Earth is a field that is just there. Whether there is something to feel it, to test it or not. So whenever something is there, it gets dragged in. So with light, we can barely tell because it's so fast. But it must happen because if we assume light bends because of acceleration, which makes sense because, I mean, light must bend due to acceleration because we fired off light when we were here. And when we're here, only here, the light should hit. Only at this time should we, oops, the thing moves. Only when we're here, only when we're here should we see the blackboard lighting up over over here. So light must bend because light has a limited speed. Because of that, light must bend. And
And if light had an infinite speed,
and therefore what?
if light had an infinite speed, it wouldn't bend.
Correct. All right. So
Hmm.
how does this explain gravity? So what is gravity? What are you doing?
Uh, I'm just, I know I'm bored. Kind of. It's a
Okay.
curvature of space time, man.
What?
The curvature of space time,
I don't
man.
understand. Wait, say it slowly. What? What is gravity?
The, curv- the curvature of space time.
No. No, that's what everybody says. And this is my greatest realization for making this video. That's incorrect. That's not going to help you.
Okay,
So what is
right.
gravity?
You tell me then.
So the way I see it, right? So you're sitting at your desk and water and light bend down towards earth. How could that be? That means, right? So what is gravity? So gravity, right? So you have earth. This is the surface of the earth is here. So earth earth is like a person sitting on his bed and the bed curves. So earth is this person sitting on the geometry of the universe and the geometry bends. whatever that means. And that causes space itself, like a river, not even a river, like a three-dimensional ocean, to flow down towards Earth. So space itself is flowing down towards Earth. And each water molecule is affected by this flow. And that's what's causing it to get as if dragged towards Earth. The water thinks, as far as the water is concerned, it's traveling as before towards the blackboard. But the water is like a ship in a river. Imagine the stream of water is like a ship in a river that is flowing downwards. That's what you would expect the ship's trajectory to be like. Let's say the ship is trying to cross from the right side to the left side of the river. And as it's traveling, the water is flowing downwards. So there's a river with a flow of water this way, and there is a ship trying to cross the river. This is the ship trying to cross the river that way. The ship thinks it's going straight to cross the river from the right bank to the left bank. So the ship is going in a straight line. What are you doing? Are you just bored? So the ship is just moving in a straight line from the right bank to the left bank. But as it's going, the flow of the river causes the ship to traject downwards. So so that is what is happening to space. And that's the explanation to
Okay. All right. This is like, thank you very much. This has been going for 20 minutes. Can we please change the topic? I'm so like, oh,
what?
ugh.
Do you understand?
Let's change the topic, man.
Can you want to try and explain to me general relativity from first principles?
No,
No.
I want to change the topic from
What
general
do you
relativity's first
what do you
principles.
want to talk about? What's the next topic?
I don't know. What do you want to talk about other than general relativity?
We can talk about whatever you want. Let's see, my latest propositions, my latest and greatest. Here it is. This is my latest proposition. Oops, wrong place.
You
So,
use this thing to make a.
I don't know how to do that. How do you tell it to disappear?
There's
Garbage.
a
Okay, got
text
it.
box.
So here is my proposition. Telling your debate opponent you need to look up, or you need to study up, or you need to study, or you should read more, or you should whatever, is a logical fallacy. You should never tell your debate opponent anything. So in a debate, you may introduce, I think I need to fix that, any claims and evidence into the debate, but you may not refer to your debate opponent except for referencing any claims and evidence they introduced into the debate. What's your opinion?
Is this title correct?
What title? You made a title? I don't see it. It says
Look,
untitled. What title? I don't see it.
here. Can you?
No. Oh, let
No,
me
here.
move
Look
away.
up.
Telling your
Zoom
debate
out.
opponent you need to do research on a topic is a logical fallacy. Correct. That is a logical fallacy.
God almighty.
You,
Okay.
you don't like it?
Why is that logical fallacy? Why is that a logical fallacy?
Because you might think that you won. You might, people who are listening would think that you got the W, but that's a logical fallacy. You did nothing. You basically changed the topic. You're talking about something. I don't know what, and I don't see how it's relevant to the discussion. Like you told me that I need to change my hairstyle. Okay, I don't know how that's relevant to our discussion. You can only a debate is that place and time when we try to change each other's minds. Period. That's it. Nothing more, nothing less. It's that simple. So if you think you're going to tell your debate opponent to change their hairstyle and therefore get the win, no. No, you cannot tell your
Well,
debate.
obviously, that just doesn't pertain, unless you're talking about hair, then that doesn't pertain to anything about the conversation. But telling your debate opponent that you just haven't done enough research to know anything about the topic to debate with me, I don't think is logical fallacy at all.
Okay, if you tell your debate opponent you don't understand the topic enough to debate, that's a logical fallacy. You're referencing your debate opponent. You're telling you first of all, referencing the debate opponent is a red herring. You're changing the topic. The topic was something else, and now you're talking about something else. You're talking about the debate opponent. That's a change of topic. So that's already a logical fallacy of red herring. But it's also a reference to the debate opponent. It's an ad hominem, as if it's relevant, as if something about the debate opponent has relevance to the discussion, but it doesn't. The only things that have relevance to the discussion are things that have relevance to the discussion, namely claims, evidence, and so forth. That's it.
Okay, well, okay, fine. Well, I'm not really willing to argue on this point. I don't think it's that important. Let's agree to disagree.
What do you mean?
I
No.
think I
Okay.
think you believe this because you get told this a lot because you just don't do the research on topics enough. That's what I think personally, but that's my own theory.
Okay. Let's agree to disagree. That's another logical fallacy. I should add
Oh
that.
my days. Can't even-
That we
everything you
don't
don't agree
agree.
with is a logical
We
fallacy.
don't know because people end debates with "let's agree to
Yeah.
disagree."
Glo-
Let's
Global warming is a logical fallacy as well, man, isn't it?
disagree is a logical fallacy. It doesn't even make sense. Let's agree to disagree. How can we agree to? I mean, I guess we can agree to disagree, but
Let's agree that we disagree on this topic.
but
Is, is that
it's
possible?
it's even if it's possible that we can agree to disagree, it has nothing to do with the debate. It's again, and
Well, yeah. Well,
it's an ad
okay, look,
hominem. You
again,
you're
I
referencing
don't
the.
want to talk about logical fallacies
You don't
with the
care about.
logical fallacy king, Mr. Slave. I'm not doing that. I'm not doing that right now.
Okay,
Let's move on. The top that this is all going. It's gone. It's gone. I'm
okay,
not debating that with you, of all the people. God,
okay. You want me to bring up more
yeah.
debate topics?
Please, please.
Uh, evidence is not a source.
Next,
You don't want to debate evidence is not a source? Yeah, let me give you my.
next,
I'll give you the
next,
link.
next, next,
I'll
next,
just give you
next.
my link
Mm.
to my debate propositions, and you can. Ah, I keep 1 second.
Just,
Here's
just
the link.
downscale it.
No, I'll just delete it.
Mm,
Okay, here
just downscale.
downscale what? It's
Okay,
downscaled. I deleted it. All right, so here
okay,
is. So this is the link. Is there a
right.
is there a God? Okay, I have that. That's in my debate propositions. So I guess you believe in God.
Yeah, I'm a Christian.
Okay. So let me
Global
see.
warming
Let me
is
see.
unscientific.
Um,
Scientific consensus is unscientific. Due to people conforming to appeal to authority and add popular logical fallacies. Schooling is child abuse. The educational system trademark is a scam. Science trademark is a scam.
here is a proposition.
Smoking
If a
may have
proposition,
many health.
what?
Smoking in moderation might have health benefits. Humans are biological robots. The Spanish flu never happened. The, the COVID pandemic never happened. Government is mathematically inept. Greta Thunberg is an international
That one's true.
I'm
Just
done.
kidding.
I'm done, bro.
You're done? That's
Yeah,
it?
I need to book. Whenever I have like, whenever I feel sad or an idiot, whenever I feel like really dumb, I'm gonna come back to this. I'm just gonna laugh. Okay. Thank you very much for this.
Yeah, anytime.
Truly, thank you. Wow.
Yeah.
You actually believe all this stuff? This is you're actually not a troll.
Yeah, I'm not a troll. That's true. That's a true statement.
Fine, sure. Caracalla, did you believe these statements on his proper his thing?
I don't think
They're debating points, right? No one truly believes those things, right?
Mr. Slave, do you think that global warming is true? Do you think it's real?
no. There's no evidence for
Well,
global
there you go,
warming.
Caracalla. Number okay, number 30. Racism is fake. Racism violates the rationality assumption. Hence, it cannot be true. Well, racism is defined as the hatred of another group for no reason. Okay.
But do you agree that racism is fake?
No, because again, you defined it wrong.
I
The
defined
hatred of
it?
another group for no
Here's
reason.
one.
Wait,
Can black people be racist?
Yes, of course they can. It depends. Well, it obviously depends on your definition of racism, right?
Well, then we're getting into semantics, but
Or
apparently, in like
semantics is
a system of
isn't.
society, since they're the minority, they can't be racist,
I think
Well,
or
yeah.
something
Again,
like that.
yeah, it depends on definition. So it's something very pertinent in the conversation. So racism, according to the Google definition, is prejudice, discrimination, or antagonism by an individual, community, or institution against a person or people on the basis of their membership of a particular racial or ethnic group, typically one that is a minority or marginalized. The belief that different races possess distinct characteristics, abilities, or qualities, especially so as to distinguish them as inferior or superior to one another.
On the West Coast, there's been attacks on Chinese people by African Americans. So
Why?
would that be considered? They're hate crimes because of
So
COVID,
the
right?
right, okay. Um, yeah, that is racist. Yeah,
hmm
again, it fits into definition, right? Prejudice against a certain racial group because of some belief that they started the COVID pandemic, which is I think is. Mr. Slave, do you think that's fake?
no, it's not racism. If you hate someone because of a reason other than the race, then that's not racism by definition.
What is it then?
Racism is only if you feel something towards someone just because of the race, and that does not exist. That's a violation of rationality. That cannot
Okay,
exist.
if there's people that if the if those Asian Americans that the black that the African Americans beat up were actually white Americans, do you think they would have done that?
That's irrelevant. So the question is,
No, it's very relevant.
no, it's not. So the
It's their
question,
race. It's
no,
very relevant in the conversation about racism.
no. So
So the question is, if they were a different race, would they have been attacked? Do you
that's
think?
irrelevant.
Bearing in mind um the motivations for the attack.
If there is a motivation to the attack other than the race, then it's not racism, right? By definition.
Did you hear? Did you hear why they were attacked?
Why? I heard the word COVID or something.
It's the belief that the
Exactly.
China started the COVID attack.
Exactly. So that's not racism.
Sorry,
You what?
okay, because yeah, I said because of the belief that China started the COVID pandemic, right?
If
So,
so, that's not racism by definition. Am I missing something?
Yes, you're missing something because those Asian Americans weren't the people that started the COVID-19 pandemic.
That's irrelevant. That's
Is relevant. They
no.
were only targeted because they were the same racial group, well, according to the African Americans who beat them up, as the people in China who started the COVID-19 pandemic.
Exactly. So that's not racism.
Okay, so they're being. Okay, I'll bring up the Google definition again for you.
Hmm.
So, discrimination or antagonism by an individual, community, or institution against a person or people on the basis of their membership as a particular racial or ethnic group.
Yes. No. No
So they're being
mention.
prejudiced
No.
on the
Yes.
basis of the membership of a particular racial or ethnic
Yes.
group. Okay,
Yes.
so that's the crux. And these Asian Americans were targeted because they're the same
No.
racial ethnic group as the people
No.
in China
No.
who started the COVID
Yes.
19
Yes.
pandemic. That's why they were attacked. If
Yes.
they were a
Because of COVID,
racial
not
group,
because of
okay,
the racial
they
group.
would not be,
It's an
and they
income.
would not have been attacked.
No.
That's the okay.
No. They
You
were
can't keep up with this. I don't know how you keep up with anything. This is basic. This is simple.
no. It makes no look. If you attack someone because of their race and for no other reason, then the question is, why did you do it? Let's say there's right, a person that belongs to a certain group or whatever, and I attack them. Why? Because just because they belong to the group, okay. But why do I dislike the group? Just because it's a group. That doesn't make any sense.
Oh, okay. Sorry. If there's motivations for not liking the group, does that make it not racist?
Exactly.
Oh, okay. Right. So, was Hitler a racist?
Well, let's assume he hated a group. Did he give a reason why he hates the group? Or is it just because of the group? Did he just hate the group, or did he say something about the group that he hated and therefore he hated the group?
Oh yeah, yeah. He said that they're causing um the collapse of society.
Then that's not racist. Then he
Okay.
doesn't like
Well, I think.
it's not that he doesn't like the race. He doesn't like that they cause the
Oh
collapse
yes,
of
it is.
society.
No, it's because
It's
yeah,
tangential.
it is because he doesn't like the race,
It's just
but he's given a
correlation.
reason for it.
But
Just because he gave no, just because
that's not
he gives no, just because he gives a reason as to why he doesn't like the ethnic group does not make it not racist. You can't give blanket justice onto a group of people that may be completely unrelated just because they share the same heritage, they come from the same stock. It doesn't make sense. It's
eh, look,
definitionally irrational.
what racism?
Yeah.
Case closed. All I said is it's a violation of the rationality assumption. You agree? That's it. I don't need to
Well, no,
say
but you just don't think it exists. An irrational thing can exist. Like the belief in the
the
Islamic God, it
rationality.
exists. But
Rationality assumption is an assumption that all creatures are rational. All humans as creatures are rational.
Kala, are you drawing?
So
What
if
is
you
this?
Yes.
so if you agree,
What is it? Sorry, Mr. Slave. What? S- Sorry, go on, Mr. Slave. Yeah,
so
what were you
if
saying?
you agree that rationality that it's irrational to be a pure racist, then case closed. That's all I claimed. If you assume rationality, then it cannot exist. That's all I'm saying. Assuming rationality, racism does not exist. That's all. That's all I'm saying. So you agree with that. And that's all I said. So you agree with the proposition. If you assume rationality, you cannot have racism. Impossible. You cannot have both. You have to choose. You cannot have both. Do you understand?
No, I wasn't listening.
Mm.
I do apologize, but I'm trying. I'm really busy drawing this guy's hair.
Okay, I'm gonna go. If you don't want to talk, I'm gonna go continue my video reviewing. One second, I have a
Oh
comment
yeah.
on YouTube. It's an ad hominem, Mr. Slavery. He calls me Mr. Slavery.
Sorry, the what to slavery?
Some comment on YouTube is in the chat that it's an ad hominem
Yeah.
slavery. Anyway, okay. So if you have any further questions, let me know. But don't make noise because I'm gonna have to come back. Are you
Well,
gonna?
yeah. What is your view on slavery? Do you think it's okay? You accept it? Think it's bad?
Yes, yes, it's good.
It's good.
Yes, I'm a slave. I
It's no
would.
good.
Why would I want to be a slave if it's bad?
Okay.
Oh, I get you. A slave to a, you know, like a MILF, like a
Whatever,
sex thing.
whatever. It doesn't matter. So telling me that slavery is bad, that's ridiculous. Obviously, to me, it's terrific. It's the best thing. It's
But
literally. Hmm. What about
what
what?
about picking cotton sort of slavery?
Well, what's the alternative? If the alternative is to die in Africa, then yeah, it's preferable.
Why why would why would you prefer picking cotton to dying in Africa?
That's just my personal preference. I'd rather basically do anything rather than die anywhere. Africa is just another place to die. So why would I want to be there? I mean, the fact is that the released slaves didn't go back to Africa. They apparently stayed in America. So Africa wasn't so hot to begin with. Maybe today people might want to go to Africa. Today Africa is
Oh
becoming
yeah.
much better. I see videos. I follow like many beautiful women, and you see that Africa is becoming really a first world continent. It's unbelievable.
Well,
It's
mm, okay, sure.
there's
But I
certain.
think the fact of the matter is,
Mhm.
these slaves just didn't have enough self autonomy to make decisions about where they could live after slavery was abolished. And so, in effect,
we
for 80 years after slavery was abolished in America,
but even today they're not.
Africans were slaves.
But yeah, but even today they're not
So,
back. Even today, that Africa is in much better shape. I mean, you can ask.
well, yeah, but,
You can.
but these are the descendants of
Yeah,
people, what, two, four, five, six, seven generational people. Now here they have a family, they have a home, they have
yeah,
place, they have communities, and they may not want to leave that.
yeah. You might ask. You might want to ask them if they're happy that they got brought over to America, even as slaves. What would they have preferred? To stay in Africa or to come to America as slaves? You can ask. You can go up to any African American or whatever person that you want and ask them. And I'm curious what their opinion is. If they would say, yeah, I would have preferred to stay in Africa, then why? Then the question is, then why aren't you? No one is stopping you now from going there. So why aren't you going now? So
Sign
apparently,
your name.
so apparently you're happy that your ancestor got brought over.
Don't leave my name.
What?
Sorry, we're drawing something.
But that's not even the point. That's not. I'm not even arguing that empirically. I mean, I'm arguing from like even today, slavery is good. If two if two
Really,
if two consenting adults want to be one the slave of the other, then leave it up to them. The law that ended slavery
and if
says
they don't consent,
what?
if they don't consent, what happens then?
The question the question is, what's the alternative? Let's say I tell you it's either I kill a person or I make him my slave. What would you choose? What's your preference today?
To dying or being a slave?
No, but okay, you okay? I'd rather be a slave than die. So to me, slavery as an option should always be open. I mean, if I had to
I'd
choose,
rather,
if I had to
honestly.
choose, if I had to choose
What kind of slavery is it? Sorry, is it? Is it chattel slavery, indentured servitude? What's going on?
any type of slavery. So if you let me choose between,
Well, there's a broad
yeah, it doesn't.
spectrum.
I don't care.
Sorry, I'm cutting you off.
I don't care. I don't care what. So if let's say you gave me two alternatives: become homeless or become a slave. What's your preference? So as long as you know, as long,
Oh, I'd be homeless.
okay, I wouldn't. I want to be a slave, and I think
Okay.
you need to let people
Yeah.
choose. The fact that the 14th Amendment doesn't let people choose, that's terrible. You, what do
Okay.
you mean? You're taking people's choice away, and you pretend to ride some moral high ground. That's ridiculous. You're an
Okay, it's the
abuser.
same thing for it's the same thing for murder, isn't it? We should give people the choice of whether they want to be murdered or not.
Of
Because if you're taking
course.
away, is why? How dare you be on the moral high ground?
What do you
It's
mean?
horrible, isn't
What do
it?
you mean? People
That is
should.
horrible.
What do you mean? A person should be allowed to die. A lot of people want to die. Like people that like like don't want to live. They want to die. So of course they should be given the choice if they want to die. If I want the doctor to kill me, the doctor should be. It's between me and my doctor, and the doctor should be allowed to kill me. And if I want somebody else to kill me, let's say I want to die. Either way, I want to die. But you know what? If I let this billionaire kill me, he's going to give me, my family, my children, $1 million. But he wants to chase me down like a hunted animal. Perfect. What could be better? What could be
Okay.
better? Why are you stopping this?
Mm,
I want to die.
yeah.
I want to be murdered. And this guy wants to murder. What could be better? And he wants to pay me. He wants to pay my children. And you're saying that you're riding the moral high ground because you're going to
Look,
prevent
Carla.
what?
Sorry, Karen.
You're going to you're going to prevent this transaction between two consenting adults, and you claim to have the moral high ground. That is ridiculous. You are evil. You are pure evil. You are pure evil. Let's add it as a proposition. Propositional logic. Okay, proposition, it's going to be 97. I should be able to make a legal transaction whereby I am paid to get murdered. For example, if a billionaire wants to hunt me like an animal and pay me $1 million, where's the dollar sign? Dollars for it, then we as a society should not object. Indeed, how do you spell indeed? Double E? Indeed, objecting to this is evil. I would say is highly unethical, aka evil. That's my proposition.
Interesting.
What, you disagree?
Uh, all I said was that it was interesting. I mean, if
Yeah.
I think it'd be, hmm, I don't know. It's very interesting.
I mean, why not? Why not? I mean,
I'm trying to think.
I mean,
I'm trying to balance this with this libertarian, free will, all this stuff with my Christianity. I'm trying to think.
the person wants to die one way. Let's say I have terminal cancer. I'm gonna die in a few months. and I'm gonna live in pain in the last few weeks. So the pain is already started, and I can't. I'm already throwing up all the time, and I'm losing my hair. So I don't want to live anymore. That's it. I want to die. Now I could either pay a doctor to kill me, and not even that. In America, that's probably illegal. So I would have to fly to Switzerland and pay for the flight, for the hotel, and that's going to be expensive. And the actual death, that's all very expensive. Now, here's the alternative. I can get paid a lot of money to get hunted down like an animal, which is, it sounds like fun, and then get murdered like an animal. Hey, I want to die. It's perfect. I want to go out how do you say, in a glaze of glory, in a
Blaze,
blaze of
blaze of glory.
in a glaze, like a donut, like a glazed donut. I want to go out in a blaze of glory. Why not? Why
Yeah,
not?
yeah, why not? Why shouldn't I be able to sell my, I don't know, sell
Exactly.
my arm, give away my
That's
brain, I
also
don't know.
true. Here, that's another problem. I should be able to sell my organs. Of course, that goes without saying. Anytime I make a
Mm.
proposition, it scrolls all the way to the top. I hate it. I hate it so much. Okay, I should be able to sell my organs.
Mr. Slave, Mr.
What?
Slave.
What?
Look at the whiteboard.
I
Do you want a whiteboard?
I see. I mean,
Look,
you
you're
guys
making you're
are
making
absolute
you're making it really big.
artists. We should, you know what? We should save it and sell it. I think you call it not a PDF. They have like
Yeah.
an ETF. No, what do you call it when you have a cryptocurrency based on a painting? You should sell your
No idea.
art, but sell the original art. You call it an ETF? What do you call it? An MT, like a uh,
This is beautiful, Caracalla.
yeah, you guys are, naturals.
Do this one. Do this one.
Okay, do you want to discuss anything else? Did you know that the Hamas is just an extension of the Israeli? Oh, he's gone? Oh, okay. Oh, he's back. Aviator, why did you go? You
My bad.
scared me that you left. You terrified me.
I was trying to cut. I was trying to get rid of the whiteboard, and then I left the thing by accident.
Oh, I think maybe I can save it. How can I save it? I saw before Untitled. How do you save? They. How do you change the name? That's the question. Oh, Untitled.
Go
Oh,
top
there.
left. It says
Oh, I don't
Untitled.
have permission. It doesn't give me permission to change the name. So I'm
Oh,
not.
I made the whiteboard. So.
Oh, okay.
Okay.
Anyway, so let me see. I've been here for an hour and a half. I need to get back to my review, but maybe I'll do that later. Okay. Does
I'm
anybody
not
else
sure.
give a topic? Does anybody want to talk? Ask me questions? Ask me anything?
Hello, is this your room?
It's my room, yeah.
Are you a physicist?
Am I an ethicist?
A physicist.
No, I'm not a physicist. I'm nothing. I'm everything and nothing. I'm a generalist.
Well, actually, I was curious because of the name of the room. So I was like, I'm interested in physics myself. So I was wondering, if we could have a physics discussion. But okay, it's fine if not.
No, we were actually, before you came, we derived a little bit of general relativity from first principles.
I see.
So we derived the bending of the geometry and the flow of space. So I actually have a theory to explain gravity based on general relativity.
How about isn't like gravity one of the four fundamental forces? Like, why do you need to explain it? Like, it's just axiomatic, right? It's like self-evident. So, why does it need explanation?
Yeah, so Newton said that he doesn't believe that the force of gravity is mediated by the vacuum. And anyone who believes that is crazy. So you need
Why?
what?
Wait, I thought it's like just like a property of matter, isn't it? Like masses have like a force between them with like g m1 m2 upon r squared. So like this is
That's Newton derived this, yeah, from Kepler's equations, but it's just a derivation. It's not a theory. Newton didn't come up with a theory of gravity. He
I
said
see.
what?
No, sorry, I didn't mean to interrupt you. I was just saying I see.
Right. So so a theory, the way I understand science and the way I care for science is science is not just there to look at the data and write mathematical equations to summarize the data, right? You can draw a line through a bunch of data points and then come up with a formula or an equation to describe the data if you ignore the errors and such. But
Mm-hmm.
I would say that's just data collection. So just realizing that you can summarize, that you can express the data mathematically, I wouldn't say that that is science. It's nice to collect data. It's nice to appreciate that you can summarize the data in a small equation, but that's not science. Science is your is our attempt to explain the data and the mathematical equation that represents the data.
Right. This is well. So one question I would have is that would you say that maybe in the like if you keep asking like whys like when in case of science, right? Would is there something at the very bottom which is like axiomatic and self? So what I'm trying to say, I'm not articulating this very uh, well, but for example, if we ask what causes gravity, so I know that there's like this one theory in quantum field theory that says that gravity is caused by artificial virtual particles called gravitons, like how electricity, electromagnetism, and strong and weak nuclear forces are caused by photons and gluons. But then the question becomes, what is a graviton? Like, how do we know the nature of graviton? And once we find that out, maybe we'll have to find something else out, like what is the nature of the thing that makes a graviton? So, like, do you think there's like an endless pit, or like there's some end to it?
I would first of all say that's irrelevant. First of all, that's irrelevant. It's a good question, but it's irrelevant. So going just to before we go to your this question, first of all, so about so Newtonian gravity is just a summary of the data. That's all it is. Um, Maybe it's a little bit of a theory, like you say, like the way you see science. Going back to your last point, it's like an onion with many layers, and who knows if there is a, like a center to the onion. But if you've ever opened an onion, it's like I think the center is microscopic because there's always a center and a center and a center. Who knows how small the actual center is? So but you could say that Newton peeled off one layer because Newton said that all objects, this is something that Kepler didn't realize. Kepler just realized that in the planetary motion, a planet covers, if you draw a triangle over time and then another triangle over time, whatever.
I know about the Kepler laws. Yeah, we can move on.
Right. So yeah, but there's other people, and by the way, this is recorded on YouTube. So right, but Kepler, so Kepler realized a law of nature, which is, and you could say it's another layer of peeling the onion. And then Newton said, yeah, that's caused by a force of gravity between the sun and the planet. And then Einstein came and said that force, but Newton said, yeah, but what is mediating the force? It cannot be the vacuum between the object. So there has to be something mediating the force. And Einstein came and he said that it's the geometry and I would say the flow. I would say more than I would add on top of Einstein, I would say it's the flow of space on the geometry, and the flow of space, that is what's causing what looks like an attraction between objects, and that flow of space actually that begins to sound like your quantum theory of gravity. That's already space itself, like that virtual the virtual particles, which that might be the ether, that might be the fabric of reality, and that might be space itself. But it seems that space itself flows into gravity, into masses, or energy, into these sinkholes like water. So there is this flow of space, and the flow of space, everything exists in this water, in this liquid, and is moved and moves in the liquid. And if the liquid flows into the sun, then anything you drop falls into the sun. It doesn't fall, it just it's swept by the stream of the water, of the liquid flowing into the sun.
I have a question.
What?
So I had a question.
Go ahead.
When you say that the space flows into so like is it well when water flows into a sink, it's usually going somewhere. So when space flows into mass, I reckon it flows into like what happens to it? Like does it just disappear after it collides with mass?
I don't know. I don't. There's many, like, even in special relativity, we already see this space time, what Einstein called space time. It already comes up. So this object, this space, it appears to be stationary with respect to every inertial observer, which is already a contradiction. So this thing, this space, it violates our intuition, at least in special relativity, and now again in general relativity. It violates our intuition because it flows from nowhere. It flows from empty space. It flows from where? I don't. But it flows into mass, and it doesn't cause the mass to become heavier. Space is weightless and frictionless, but somehow it does drag things without being without friction. There's no loss of energy. There's no energy
Hold
loss.
on.
Right.
What?
That guy. Quick question. So you said you're interested in physics. Are you like a student of it? You studying?
I'm an engineering graduate, so not
Oh yeah.
exactly a physicist, but do have some background knowledge in physics. Yes.
Yeah. Okay. I see. Um. Right. Good to know. Sorry, if you could carry on, Mr. Slave.
Yeah, but the question is it's really good because right. So I came up with this model. It's not me. I've seen this model. Other people, I think Science Click. He made a video in which he used the analogy of water, but it's just an analogy. and it's a surface water, I'm using water not as an analogy, but more as a model. And I'm using it three dimensionally, not two dimensionally.
Uh,
And
But hold on, wouldn't that like be inaccurate, right? To use water as a model, because water it doesn't accurately explain everything that's happening with general relativity and that, right? So it'd be better to use it as an analogy, correct?
but no, Science Click. I don't know if it was Science Click or one of the really channels that I really respect a lot. I think it was Science Click. So he used it really just as an analogy, and I pointed out in the comments that there is actually a problem because in his analogy, the water was stretching, and we know water doesn't stretch. So in my model, there is no stretching. Stretching would ruin the effect. So there is no stretching. It's 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 exactly like water, except for an inertial observer, this water is stationary with respect to the inertial observer. So the planet Earth doesn't lose speed because it's moving through this space, this flow, because relative to Earth, the water is stationary. So it's it's really weird. But this already comes out in special relativity. It's already weird then that light. But there's ways to resolve it in special relativity. I haven't finished modeling it, so I end up with.
I had a question. Could I ask a question?
You have a question?
Yeah, I have a question.
Go ahead.
So you do not believe in the graviton model of the gravity, like you don't, and I'm just wondering, like, was there disagreement with it, and like, how did you come to the conclusion that it's actually space that's flowing into Mars? Like, is there some experiment that shows that? Uh,
I mean, otherwise, right? Newton had a question. No one answered the question. Not even Einstein. Einstein just talked about the bending of the geometry. But
What was the question?
so the question was, do I have any evidence? I think, or something like that. That guy, do you want to repeat your question?
Yeah, so I was like, there are always different theories and models that explain gravity. One of them comes from the quantum field theory, that gravity is caused by virtual particles called gravitron. So I'm just wondering, like, why do you disagree with that? Like, and why would you? What made you go towards the other theory of space flowing into Mars?
Forgive me if I'm wrong, but the graviton has ever been observed ever. It's just a theory, and countless attempts at trying to find the graviton have failed. Correct?
As far
Wait,
as
so yeah, sorry, go ahead.
As
Go
far
ahead.
as I know. So I mean, so far there's nothing to prove that it actually exists. I mean, with other subatomic parts, sorry, with other particles like the Higgs boson, W boson, they've actually been found. They're proven to exist. The observations fit theory, but so far nothing for the graviton, right?
right, so I would make a prediction based on my theory. I would make a prediction that there is no graviton. I don't need the graviton um to explain gravity. I don't know why people. I've never understood this need for a graviton or quantum gravity. I never needed it. People needed it, apparently. They said because of the singularity at the center of the black hole. So I never thought there was a singularity. And like a couple of months ago, Professor Kerr.
Well, no, it's because we discovered quantum objects, right? Like the photon,
I don't know. I don't
uh,
look. I've made videos over a year ago where I already said that there is no singularity at the center of the black hole. Since then,
again.
what?
But the reason why we're trying to find the gravitons is because we found um all the particles that make up the other four fundamental forces, correct?
Yeah, but
Yeah,
but we
correct.
but we don't.
So it just only follows logically. We say, okay, well, it's got to be another a graviton because there's other quantum objects that make up the other four forces. So not because I haven't ever heard about the singularity that you're talking about.
Okay, I mean, I don't. It might be that it's actually gravitons that are involved with what I call space. It could be. It could be the case. I don't know, but um, I don't know. I mean, it wouldn't contradict. It wouldn't contradict my theory. It could be that there are gravitons and they flow through an apple, and that is what
Huh?
looks like. Yeah, go ahead.
Sorry, no, no, I'm just sorry. Ignore me. I'm just chuckling to myself. Carry
Okay, why are you chuckling? Is it because of me?
on.
What's so funny?
No, sorry.
What? Share the joke with the rest of us.
It's nothing. Sorry. Continue.
Anyway, okay. Anyway, so I don't know if there are gravitons, if there aren't. It could be. What definitely I know, as far as I know, I've heard many, many, many people, the greatest of the scientific community, as they say, explain gravity according to Einstein, and it never made any sense to me. And yesterday or 2 days ago, I was talking to myself. I don't remember when it happened. As I was talking to myself, pacing back and forth in my living room, thinking about general relativity, or during one of the videos as I was talking to someone, but it came to me that if space would flow, then that would explain gravity. Space flows. So right now, space is flowing through me really, really fast downwards. And that's the suction that I feel downwards. It's because space flows towards Earth. Earth is a gravity sink, it's a space sink. It drags in space. I would say that it bends the geometry. There is some geometry in the universe, and a mass bends the geometry, and that causes space to flow in accordance with this geometry. And a mass creates like a suction. It's like a vacuum. It swallows and swallows. It endlessly swallows in space, and it causes a drift. It causes like a three-dimensional river. It causes the water, the liquid, the space to flow from all directions, and anything in in the vicinity is moved by this motion. As you get closer and closer to the Earth, the flux is higher, meaning the speed of the stream is higher and higher and higher because the water does not stretch. So it must be that the flux, the flow of water over any surface, closer and closer, or through any volume, closer and closer to the Earth, must be faster and faster because of Bernoulli's law. Actually, Bernoulli's law explains explains gravity, or is part of it. You can actually use Bernoulli's equations. You don't need to because Bernoulli, it's a little bit, it's an overkill. Is it Bernoulli who made the flow partial derivative? Anyway, so you can actually, so anyway, that's the explanation. Now, what how What about space that is flowing through me right now is dragging me down? I don't know. Is it gravitons that are interacting with me that's dragging me? I don't I don't know, because even light, so even light that you can view as a wave, so even light bends. So it's actually this, it's not gravitons that move through space. See, the problem is that gravitons, they would move through space, and we need space to move. Otherwise, why would light as a wave be bent? Why would a light beam bend because of gravitons? How? What's the interaction between I my intuition is that there's no gravitons. My intuition is it's space itself, and therefore a light beam traveling in a straight line through space, but space itself flows towards a gravity sink. So the light bends. Now it bends just a little bit because light is so fast, and the space itself moves, is, it's not fast moving, it's slow moving. And by the way, I already we can calculate how fast space itself moves. But this also explains
So,
what.
hold on, that guy. So, what do you think about the graviton? Do you think it exists? Do you think it's a valid theory?
Well, I don't know because that's what I've heard that how people like to explain like electromagnetism and virtual particles such as virtual photons and virtual gluons. They are shown to be like they're real, right? But I'm not sure if
Mm,
gravitons are real because uh, people have not established that they're real or whatever. But that's kind of how gravity is a bit different than the other four fundamental forces.
mm, yeah. I don't know. I just feel like when you find when you just make a model after after pacing around your room, and then you find theory like problems with that model, I wouldn't be surprised, right? 'Cause you didn't really do any maths or experiments or to create this model. You just kind of thought up the model.
Yeah, but Einstein derived special and general relativity just from thinking, not even walking. The trick is to think.
Mm, I don't know.
What do you mean? I mean, as far as we know, I mean, relativity is just based on
A lot
thought.
of maths, right?
No, no, the math is just to express his thought. The purpose of the math is just to express the notion, the intuition. Everything I said can be expressed in equations, and I guess that would be the equations of general relativity. I could also
Mm,
express it in the equations, in Bernoulli's equations.
interesting. Hmm.
Let
Well,
me see
uh,
the name of Bernoulli's equations. I don't remember. What is the name of these equations? They have a name. Is it Bernoulli's equations? Do you remember that guy? Do you remember the name of the equations that describe the flow of liquids?
There are several ones. So one of them is the mass continuity equation. That would be flow rate is always constant. So A1 V1 equals A2 V2. The other one would be energy conservation equation. That would be the streamline in which in a streamline the energy is always conserved. So static pressure plus dynamic pressure plus kinetic energy is always constant. Those are the two.
No, but there is a set of four equations that
this guy is
describe.
like
fluid
Einstein.
dynamics, the equations
How
I
long
of
have you
mean,
spent studying? How long have you spent studying engineering?
sorry, what?
How long have you spent studying engineering? Because you're like a weird, like a maths whiz. You're gonna pop up any equation off the top of it. How long? How long have you been doing it?
oh yeah, it's called the Navier-Stokes equation. So I can describe
Wait,
gravity.
chill out, chill. Wait, wait, that guy. What how long have you been studying engineering?
I've already graduated.
Graduated. Okay, right. Do you have a job now?
Yeah.
Oh, right. Okay. So like, what do you do? Um, yeah,
Well, I'm an engineer. I kind of don't want to answer more questions. Sorry.
that's fine. Sorry, I don't want to encroach on your privacy. I'm just really impressed. Like genuinely, it's very very cool. Um, yeah. I mean,
One more thing, Navier-Stokes is just one equation. The four equations that you're mentioning are just like they spread it into different like different what's it called? Like the different three dimensions of space. So like it's just one equation. Like when you say four, like it's in x, y, and z direction. That's how they like. That's three of them, and there's also a time variable. I'm forgetting, but I think yeah, this is one equation.
Yeah, yeah, I'm looking it up right now. Yeah. So I
you know,
think.
I'm thinking about. Sorry.
No, go ahead.
I'm, I was just gonna say. Um, I'm gonna study physics in college. In September. So yeah, I mean, got something in common, don't we? Uh,
Good luck with that.
yeah. Cheers.
So um so that guy, let me ask you a question. So based on my theory, just from my theory, can you deduce Newtonian gravity? Can we deduce Newtonian gravity from my theory? Right?
So just to make sure that I'm on the same page as you, when you say Newtonian gravity, you mean G force equals G m1 m2 upon r square, right? That's what you mean.
Yes, exactly.
Um, well, if you're saying that, for example, that space is a fluid type thing which flows into mass, and mass acts like a sink, and like I guess space just disappears into the mass, or you don't know what happens to it. Maybe and maybe I don't know, like I'm honestly like no, this is just I'm just having a bit difficult time understanding this. Like nothing against you. Maybe it's just because it's the first time I'm hearing this type of theory. Uh, but sure, I guess like because gm and m2 upon r square is just an observation, right? Like it's an empirically derived thing, which is like somewhat axiomatic, I guess.
I
So
mean,
sure, why not?
no, no, no. The question is, can we predict like Earth orbit based on my theory? I'm going to use Navier-Stokes to predict Earth's orbit. If we assume
Oh,
the Earth
well,
moves in a yeah,
I
why?
mean, name. Yeah, go ahead. Sorry, go ahead.
I'm just thinking, like, why? How do you? How? No, I don't understand. Like, how do you know where space is coming at any given time? Like, what direction is it going in? Does that correspond with the direction of where the object is going? I don't know. How would you?
so
I'm still thinking. I don't understand
I'll
it.
give you my assumption. So my assumption is that, for example, the Earth doesn't experience friction as it moves through space. As long as it's in as long as it is inertial. Any inertial frame of reference doesn't experience friction with space. Space is stationary relative to any inertial observer. So the Earth, you can view it as an inertial observer. So the for the Earth, this water is stationary. So the Earth doesn't care. The Earth is not going to slow down. The Earth, as far as the Earth is concerned, it's not moving. It's inertial. It doesn't care if it's moving or not. It's at a, it. it doesn't care. It's in free fall. The Earth is in free fall. So any object that experiences free fall is not going to experience friction. So there is no friction in this model. That's an
So if you're like, yeah, to answer your question, if we can like predict the Earth's orbit using Navier-Stokes, well, if you look at the Navier-Stokes equation, so like three heads there. I mean, three different three terms in the equation. One of them is the pressure head, one of them is the velocity head, and one of them is the mass. One of them is the friction head. So I guess when you're trying to like, it only works for fluids which have like mass and like or subs like can develop pressure. So like you have to like if you're defining space as a fluid which has no mass, I'm like even trying to like I don't think like it would even how would you even define pressure like in terms of
no, you're right.
I
You're
don't know
right.
like
No, you're right. Navier-Stokes. I'm understanding now is irrelevant. Yeah, it's a different model, obviously. Yeah. So so I'll give you the model. The model is that you can view it like water because it doesn't change density. The density is constant. It doesn't stretch. It doesn't compress. But there's no friction. There's no loss. There's no energy loss. Wait. Oh, people left. Okay, so we're alone. It's good. So there's only so there's no loss of energy. There's no loss of velocity. Anyway, so the you can view the Earth. The Earth moves in a straight line through this
Mhm.
liquid, but there's no friction. So its velocity. So just imagine a frictionless liquid. What do you call friction? It's not called friction. It's called viscous. It's zero viscosity. So let's imagine where we have a liquid that has zero viscosity
Yeah.
in the direction of the
The word
it's strange. In the direction of the inertial motion, it has zero viscosity. But in terms of gravity, it has exactly the degree, the percent viscosity is 100%. So the sun pulls in this viscous liquid, and anything gets perfectly dragged in as if they're sitting on a carpet that is moving towards it. But so
right.
the earth is moving in a straight line away from the sun, experiencing zero viscosity. But as this liquid is dragged into the sun, the earth is experiencing perfect viscosity. So it might as well be rope, a string, an unstretchable string tethered between the earth and the sun. Well, it changes. I mean, it can stretch, but the amount. So it's a weird model, but I mean, I think this is just what I'm describing is just the equations of general relativity. But instead,
Right. Just to make it, I think like just to clarify some terms, I think that will help you with your model as well, right? So viscosity refers to the internal resistance of a fluid. So like you're right, like it kind of it defines how much like if you were to move like a stick to stir a liquid, how much resistance it would give to your stick, right?
yeah,
So like it is correlated to friction. So you're right in that sense. So when you but what the word you're looking for is inviscid, so like a fluid with zero viscosity. That would be space. But then, as you said, that the space is moving in the direction of the mass, and is in that direction has zero viscosity. But when it's like some object is sitting on top of space, and then it experiences infinite viscosity, I guess.
yes,
So right. I don't think that there's any fluid like that in real life which has like anisotropic frictional properties. Like there are solids that can do that. I really doubt that there's any fluid which can like which has zero like can exhibit variable viscosity in different direction because that's not how fluids work, right?
I understand.
Particles are not that's
I understand. I
yeah.
understand. I mean, but the question is, can we deduce the equation of Newtonian gravity from this model?
Well, again, you probably would not be able to use Navier-Stokes, so you'll have
No,
to
no,
come up with
no.
your own.
No, forget about. I understand Navier-Stokes is no good. Yeah, we would have to come up with. I mean, just from the model. I mean, this is like, isn't this like Gaussian flow or something? What is? Do you know what Gaussian flow is?
I Wait, let me check if I've studied this. Give me a moment.
No, I mean the like you if you do a surface integral around the sun and you would measure the flux on that surface.
Yeah, I'm afraid I have not studied this now.
Wait, but you did three-dimensional like analytic geometry. That's like third semester calculus. That's like second year calculus, no?
Yeah, we were just left at multivariate integration. We did not go that far into it's because it's not that useful for engineers. But it is taught in high school, colleges, I know.
I mean, for electrical engineering, I think it's critical. I mean, electrical engineering.
Yeah, I'm not in electrical, so it's like I know it's like a main core mathematics subject, so I'm not saying.
Okay.
But again, like my main thing is like if you're trying to again like if this is your theory, right? Obviously to prove that it works, you'll have to like make some observations and measurements. Like what would be your experimental setup to maybe measure this flow of
No,
space? Like
no,
you
no,
have some.
no. No, no, no. I don't need to. All I need to be able to do. Look, I don't have a new theory. I just think what I'm describing is general relativity. I'm just asking, can we, just from this intuition, without any equations, just from this intuition, can we deduce mathematically Newtonian gravity? That is evidence. Then we would have evidence that my theory is correct, which I think is just general relativity. It's not more than that. I'm just skipping the math. I'm just skipping the math of curved geometry. I'm doing the curved geometry in my mind as a thought experiment. I'm continuing the thought experiment of Einstein. Instead of skipping
Mhm.
the math, yeah, go ahead.
No, well, in that, yeah, I'm a bit helpless in that because I have not studied mathematics in that detail to hell be of any use in this. Because you'll have to again imagine space as this like weird one-directional viscid, inviscid fluid. Like it's yeah, I'll probably have to. I won't be able to help you there.
Right, but just as a, I mean, if you measure, I mean, if you think of the sun as a gravity sink and water
Hmm.
flowing, let's say water in space, so there is no change, there is no pressure. Pressure is zero, and density is constant.
Right.
So we have.
Well, I'll, I'll have to ask you if pressure is well, flow in water happens only because of pressure. Like fluids flow because there's like a pressure difference between 2 points. That's like the main reason why fluids flow.
Okay, okay.
So if
I
there's
meant
like no,
I meant there's no pressure due to gravity. That's what I meant.
okay, all right,
Like
yeah, got it,
like
got it.
we have a very deep ocean floating in outer space. It's a huge cube of water. Let's say like a kilometer by kilometer by kilometer of a pool of water enclosed, encased, floating in outer space. So there's the pressure.
Right.
So the pressure is zero, and the density is whatever water is, and that's fine. And now we put a sink at the center that is sucking in the water, and let's say
Right.
we're refilling the pool from all sides. There's whenever there's a little bit of a vacuum, it just sucks in water. So there's water being added from outside all the time, as much as is needed to keep pressure at zero, whatever. And we're sucking out water from the center.
Hmm. Yeah,
So
no, I understand the hypothetical. Like it's like this in this hypothetical cube of 1 kilometer or whatever dimensions is floating in space. That's like and you put in like some sink in which the water just goes and disappears, and from the boundaries, more water just comes out. Like it just emerges. I understand that, but like you would still have to like make some like derivations, like mathematical or empirical observations, I should say, of how or what like how does mass that this sink is, how does it affect the flow of this water, like how does it increase if there's more mass, like does it increase the speed of
so
flow of
let's say
the water
let's
inside?
say let's say the mass is zero. It has no mass. I don't want it to have inertia. So there's no mass. The water particles have no mass.
Right, no, I'm not talking about the water particles, I'm talking about the sink, because sink is gravity,
Oh,
sorry, mass, right?
right. So let's say in the beginning it sucks out 1 cubic meter of water per second. When we
No, that's
turn
not my point. My point is that's not what I'm saying. I'm saying that the nature of the sink, how do you correlate that to mass? Because we can say that the more mass there is, the faster
yes,
water or space flows into it, right?
yes, that's just
So how
mass.
do you
So if you
right? So
double
how do you
if you
like
if you double the mass, you double the rate of water that the sink sucks in per second. So if you double the mass
right?
in the analogy in the model, you double, like let's say from 1 meter cube per second to 2 meters cube per second. That's equivalent to
Yeah,
doubling the mass.
yeah, you can do that. I don't think there's anything wrong with that, but you'll have to like define this like flow, like like you gave me some random number, right? But I don't think you have any empirical or like whatever like observational data on what is this flow rate. Like it could be 1 meter cube or it could be 2 meter cube of space flowing into some quantity of mass. So you'll
So
have
I
to
think
deduce that.
I think we can figure it out because we know that, like, I think that my intuition is that, let's say there is only Earth in the universe. Now,
Yeah.
let's say we put a person at infinite distance from Earth. So that person is going to start getting pulled into Earth, right? It's going to move, it's going to accelerate and accelerate and accelerate towards the Earth until he hits Earth, right?
Yeah.
So I would say that if you follow that person's trajectory, that is the flow of space, because that person is a test mass. Any mass would behave that way. If the person weighed double or half or 1 millionth or 1 billion times that person, it would fall at the same rate because all objects fall at the same rate towards Earth. So 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 even so space itself, which is massless, should fall into Earth at the same rate. So we can calculate the speed or the flow or the flux. We can calculate how fast space moves into Earth right now at surface level.
Right. Yeah, you do that, and then you also has to uh like deduce how that thing space as it's flowing into some mass drags another mass which is sitting in space, and like that causes gravity. Like you'd have to deduce that mechanism as well, right?
Okay,
And that will, I think that, yeah.
but all I want right now is using just a few assumptions. I want to be able to deduce Newtonian gravity. I want to I want to be able to say, my point is, I want to show, at least to show, that the inverse square law applies. That this that
Right.
that
Well,
that that
yeah.
the force experienced by a test mass anywhere in the field, in this field, we can describe this field in a vector. This could be just a vector space. We could describe this using a vector equation, like a vector equation, right?
Mm, well, force is equals to mass times acceleration. So if, like, let's say
No,
there are
no,
two
no,
bodies in space,
no, no. The test mass
I
is
know, but
massless.
I know.
I don't need
I'll
mass.
tell you what I mean. I'll tell you what I mean. Well, obviously there's the fundamental force of gravity, but there's also the equation for force given by Newton. That's F equals mass times acceleration. So you have to demonstrate that this force is the acceleration that some mass gets due to the presence of like another mass dragging this mass with like the space with sucking space inside it, like acting as a sink for space. You'll have to demonstrate that's causing acceleration in that said mass in the test mass, and that you will have to demonstrate that this is equals to f g m1 m2 by r squared. Like that's the way to do it.
Not exactly. You don't. That's like there's extra steps in what you said, because you can take Newtonian gravity and express it as a vector space, regardless of the test mass. Because any mass, right? If you replace Earth with another object, it would stay in the same orbit. Because all objects, because mass cancels out, because F equals ma on the left and gmm over r squared, there's m, the two m's cancel out on both sides of the equation. So it's not F equals ma, rather F equals a. So instead of ma, you can just say acceleration a equals gm over r squared, and you can ignore the mass of your test mass. So A equals, which is a vector space. So you can, a vector field. So you can express, do you see my blackboard? Right? So you can say,
I'm not in the activity. Should I join the activity whiteboard?
try to join it. So MA equals G capital M, just the mass of the sun over R squared. So you don't, sorry, it's not M, it's, right? The M's cancel out. So it's just A
It's
equals,
opening.
which is,
The app is okay.
and A is a vector field because it points at M, at the location of M, at which is, let's say, at zero, whatever. It doesn't matter. So you have a vector field. So you can express Newtonian gravity as as a vector field.
Well, you'll have to. I see what you're saying, right? I'm kind of also curious how you will prove how you'll get the value for the gravitational constant to this model. But as discussed earlier, you'll have to probably show like that the mass capital M here, the mass of this, like the mass of Earth, for example, pulling Moon towards it. So small m is Moon's mass gets cancelled. So you have to demonstrate that the mass capital M, that it's pulling space, or space in itself in as a sink at some flow rate, and you'll have to establish that again that flow rate is somehow correlated with this vector field A, and that should do it, right?
Right. So
I'm still wondering like how you will derive the gravitational constant. Well, yeah.
no, that I don't think Einstein derived the gravitational constant. I don't think you can derive the gravitational constant. I don't
So you're
think.
just going to leave it as like an empirical observation. I mean, okay, that's fine as well, I guess.
I mean, all I want, right? Because I need the speed of the flow of space. So that's empirical, and I get that. I told you, from dropping a test mass from infinity and seeing how fast it is when it reaches the surface, let's say, of the sun from infinite distance.
Mhm, mhm.
So that's the speed of that. That's what we call flux in analytic geometry. That's the speed of of the space through the sphere of the sun, like a three what it's a 3D integral. It's a 2D integral over the surface. It's a surface integral, and that's the flux is flux is defined as just whatever. It's not important anyway. So we get the speed of the flow of space, and we can calculate the speed of the flow of space anywhere. We can actually derive a vector equation, a vector field of the flow of space, and it should be it should be the same. It should be exactly what I already wrote on the blackboard.
I'm thinking about it.
Where m
Let me think.
m is the flux at the sun. M would be the flux at the sun. Let's call it F. And it should be, oh, it's impossible to, how do you move this? Okay. So it should be some constant. Let's call it H. It should end up being the same. So F should be, F is, the question is, and this is the flow, the flux at any, the vector flux is equal to the flux of the sun times some constant, which is should be come out to be equivalent. If we set, I mean, if we use, instead of get out of here, instead of H, if we actually use G, then we define the flux in such a way. I mean, we have to play around with the numbers, but the question is, do we get the inverse square law? That's the only question. I mean, this is the only question that Newton had. So when Newton looked at Kepler's equations, all he said was, what equation gives me the equivalent area triangles over time? And then somebody told him, oh, it's the inverse square law. And he said, oh, fantastic. Then I have the universal law of gravity. Ta-da! I think somebody told him. He didn't even know it. Like he just connected the dots. I mean, fine, he was smart, obviously. So
Uh,
so the
yeah.
question
Mr. Slade, it's an interesting theory. It was a pleasure talking to you. I'll have to take my leave now. I'll see you around. Okay?
Yeah,
I'll see you
thank you. Have a great day. Bye.
Bye.
All right. All right. Good discussion, 2.5 hours. Let's see what comments people have, and then maybe we'll stop because it's 2.5 hours. So Birdnest Rat Fest says, glorified is the creator. We are stumblers stumbling around, bumping into the already existing truth. I don't know why you would say that. Why do you glorify the creator? We have no access. We will never have access to this idea of a creator. So I don't know. I have nothing to say and will never have anything to say about the creator. And no one can ever say anything about the creator. It is inaccessible knowledge. And in 1,000,000,000 years, if aliens come to Earth and they tell us we access knowledge about the creator, I can say with mathematical certainty that they are lying. So I don't know anything about that creator. I cannot know. No one can know. Anyone who claims to know is lying. We're stumbling, we're stumblers, stumbling around, bumping into the already existing. I don't know what you mean by already existing truth. I don't know what that means. I mean, if you assume, if you call nature truth, I don't know why you would do that, but I'm just trying to figure out nature. I'm curious. I look at nature like a puzzle. I'm just trying to figure it out. That's all. I'm just curious if I can figure it out, if I can figure out anything about nature. I'm just curious about myself. It's a curiosity about, like, when you try to solve a puzzle, you're curious about yourself. Can I figure it out? I'm just curious if I can solve this puzzle. It's an interesting puzzle. I wouldn't glorify anyone. It's just a pastime. It's just fun, and maybe something positive will come out of this endeavor. Maybe not. I don't care. It's a game. It's an endeavor. It's an intellectual. I think this is what it means to be an intellectual. It's just being like I'm just curious. It's just a game. That's all. Once Almighty mentioned the planet's motions in Quran, science kick started all Greek Roman mistakes corrected. Once Almighty mentioned the planet's motions in Quran. I don't know. I don't know. First of all, you say Almighty. I don't know what is Almighty, because even theoretically, the God who is Almighty cannot create a rock that he cannot lift. So he is not Almighty. Almighty is a contradiction of itself. So you cannot be Almighty. So that's not true. Nothing is Almighty. Nothing can be Almighty. You can be mighty, but not almighty. You cannot do what you cannot do. So that's not almighty. That's somewhat mighty. Mention the planet. Anyway, I don't know what you mean. Why don't you come on to the debate and discuss? Earth's shape, Earth circumference. I don't know what you mean. I don't know what you mean. But thank you for the comments. It's good to have comments. I like comments. Okay, everyone. I think we're gonna stop here. Please, the most important thing is, I mean, subscribing is nice. I appreciate it. But sharing is actually one of the most. Everything is important. I wish if you could share this with anyone, especially someone who knows general relativity and they can listen to it. It would be appreciated if they want to come and debate me. That would be even more appreciated. Or anyone who wants to debate me about anything. I'm always looking to debate people. As you know, I try to be as nice as possible. I'm not here to hurt anyone's feelings. I'm not here to win any debate. Sometimes people they think that I'm a dummy dum dum. That's fine. And sometimes people appreciate what I have to say. That's obviously that's nice too. But the most important thing is for people to engage. I am really enjoying this engagement. I'm learning a lot from this engagement, from debating about all these topics. Anyway, so yeah, so please, and if you comment, that's nice too. And maybe can I set up like a Patreon and stuff like that? I'll have to look into that. Anyway, and maybe you can have me invited to other people's channels if you know anyone, if you are a creator or something, if you can invite me to other channels and stuff, that would be amazing. All right, everyone. Thank you so much. See you next time.